All right, good morning. So this is the assignment for Wednesday, May 20th. And today we're gonna play with some optical illusions. So the assignment is already in classroom. It's this assignment. So it is this assignment. And let's look at what we're doing. Okay, so you're gonna open up, there's in Google Classroom, you have, like we said, this right here. First thing we're gonna do is a little review. So I got four things right here where it shows the light arrows and you're telling me what happens in each. And I have reflect, refract, absorb, and one of those words will be used twice because there's four. Okay. So let's go back over refraction because we just saw it for the first time yesterday. So remember, we know that light could be absorbed, reflected, or transmitted. But now we're saying, okay, but if it doesn't just go straight through, it's being refracted, right? So like the air right here, we saw this straw is just going straight. So it would be just transmitted. It's not being refracted. But when we had it with the water and then the air up here, we can see that it's bent right there, right? It looks like this bottom half is more to the right, the top half is more to the left. And so we call that point right there is refracted. And it's because the light has to change speeds when it goes through different mediums. So it's going real fast through the air, then it slows down when it hits the water. This one over here kind of shows it again. So like through just the air, the light's traveling pretty fast. It's going right here, right? But then when it hits this like silicone, it slows down through there and then it speeds back up as it comes back out. Prism, just same thing. So light's going and then it's changing speeds, but the way when it does it in a prism, it can actually separate out our different colors. All right. Another interesting point that I wanted to bring up is why we wear glasses. Okay, so your eyeball actually has a lens in there that's refracting the light. And if your eyes work perfectly, unlike me, it brings everything to a point. We call that a focal point on the back of your eyeball, which is called the retina. And that's what sends the message to your brain. So if somebody is farsighted, that means they can see far, but then they need like glasses for reading. It usually happens as people get older. Like if you ever see your grandparents, your parents like hold the menus really far out because they can't see it unless it's far. This is what has happened. Their eyeball is actually a little too short. And so that focal point is forming behind the eye. So they wear these convex lenses. Those are thicker in the middle, thinner on the sides. And it just brings it so that the image is back where it's supposed to be on the back of the retina. People like me that are nearsighted, I can see up close, but I can't see far away. It's because my eyeball is too long. So the focal point is up here. And so I wear concave lenses. They're thicker on the sides up here and thinner in the middle. And so it just brings it to a point. So that's how your glasses work. It's all because of light. All right, so let's go ahead and open up our document that I already have here. We already went over this one. Okay, so what you are gonna do is you're gonna open up this link. And I purposely picked some optical illusions that you can try at home. So you're gonna watch this video. It's a minute 44, has music, and it's gonna show you a bunch of different optical illusions. So see, like the lines are straight here, but when you put a glass of water, it makes them look wavy. So these are the only things you would need: glass, water, vegetable oil, and drawing. If you don't have vegetable oil, any oil would work, or like a corn syrup, anything that's thicker than water that's in your kitchen. Okay. If you want to try it the other way, like a rubbing alcohol would actually be less thick than water. And you can just see some different things. So what you're going to do here, what do you see happen? So like on that one, I just said there were straight lines on the paper behind the glass, but when the glass of water was put in front of it, it was wavy. Why did it happen? Well, why did this look bent? It's going to be because of refraction. Okay, so that's what you would explain there. And I'll give you a little hint. Most of them are refraction. Extra credit if you take a picture and put it here, or right? Tag me and tag Fessler, share your learning on Instagram. I'll give you some extra credit on this assignment. So try any of these at home. There's even more. You do not have to do these extra ones, but I purposely pick ones with simple things that you can try at home. And then you can see some more cool optical illusions. And so these ones are like some of the ones you've seen. Like why they work is because these ones are more like your brain is doing. Colorblind is always a fun, good one. This one is refraction. Watch what happens. The arrow was facing the other way, and now the arrow is facing that way. And it's because of refraction. All right, so that is the assignment for today. I hope you enjoy some optical illusion fun. And then remember, the next 2 days, you do not have any new work from me. It's just getting caught up. And then don't forget in your homeroom class to work on your slides. They are due by Friday for the end of the year stuff. All right, have a great day.